Careful not to go too far that way.
Okay. So today we're going to learn about adding and subtracting polynomials. We're going to review what polynomials are because we learned them last week. We're going to learn how to combine like terms and zero terms with adding and subtracting. And in math you always get the question like, when am I ever going to use this? So you might use it to build a roller coaster. This is the Millennium Force.
It's so cute. So cute.
Yeah, so polynomials relate to roller coasters, like with the hills and everything. So if you want to grow up and do that. Okay, so reviewing polynomials. A polynomial can't be divided by like a variable, which is like x or y or any of that stuff. Your exponents can only be whole numbers, like positive whole numbers, and then you can't have an infinite number of terms. So basically, like, this is a correct polynomial, but these are wrong because you have like a negative exponent, and this one's being divided by a variable. So okay, so does someone want to come up and put the polynomials in the polynomial space and the non-polynomials in the non-polynomial space? You can do all of them. Yeah. Okay. Good job. Okay, so for grouping, basically what you need to know is that like all the x squares are like a group, all the x's are a group, all the just normal numbers are like a group. So it depends on the x whether it's like can be grouped together or not. So for grouping, we're gonna use little squares to like symbolize the numbers. So like the big squares are x squared, the rectangles are just x, and then the little squares are just normal numbers. So does someone want to come up and put the squares like where they should go compared to the polynomials? Do you kind of understand what I'm saying? So you're going to use the big squares as x squared. So you have one x squared. And then you have 4 x's, and these are labeled x's. So you can bring 4 x's over here. And then 2 ones. And then that's our polynomial expressed in squares. So does someone want to try the second polynomial? one? Okay, so now when we're grouping, we're taking like terms. So our like squares are all going to go together. So we're going to move these around so that all of our like terms are together. And then we can see if this is right. And it is. So then next, we can just write what we see. So we have 3x squared, and then we have 4 positive x's, and then we have 3 negative x's, and then we have 2 positive ones and 1 negative one. So if we add this all together, we have 3x squared plus x plus 1. Does everyone kind of get that?
Mm-hmm.
You understand grouping? Okay, and then we can check our answer. 3x squared plus 4x minus 3x plus 2 minus 1, which is what we got. Okay, so do you think we can do it without squares, or do we still want squares?
It doesn't matter.
Okay. So can somebody tell me how I do this? What am I going to add together?
11m squared plus 8m squared.
And get what?
19m squared.
And then what's going to be my second term?
It's 7 minutes, I didn't.
Oh, negative 3 plus 4.
And you get
1
Fun.
plus 1.
so C. And C is right. Yay. Okay, so can someone come up here and do this one for me? I promise it's not as bad as it looks. There's a lot of letters, but...
Okay.
Okay. So we have to combine like terms, so make sure you're looking at the p's and their
Okay.
exponents.
So
You
2p
can write two.
cubed, 9p cubed, they're both positive, so it's going to be 11. You want me to write it?
If you'd like,
Okay.
that helps.
So 11p cubed.
Are you looking at your p's? You're making sure that...
Oh, that's a square. I
Yeah.
see. So no, that's not right. So that has to stay on its own. So it remains a 2p cubed.
Correct.
2p cubed, and then I have 2 squared. So they're both positive, so then that's an 11p squared. And then I have a 10p and an 11p, and they're both added together, so that's 21p. And then I have 0 ones over here and 3 negative ones over here, so it's negative 3.
Okay, does that match any of our answers?
Oh, I'm sorry, I'm supposed to hit this one right here.
Perfect. It should be fine, but you got it right.
What did I do? Oh, okay.
Okay, and then we have one more addition problem. Does anyone feel confident that they can do this one? Nobody? Okay. If you need to, you can like put squares around the terms too to like cancel them out. Yeah, like, okay. So, see how there's like 1a cubed? You can make it like a cube, and then you have 2a squared to make it simpler so you can see it by themselves. So that way you know what you're grouping together.
So then chance that you
Hmm?
Did I push it or?
Yeah. Perfect. Okay, so now we're going to do subtraction. Subtraction is basically addition. You just have to distribute your negative sign, which we all learned last year. And so when you're taking minus x cubed minus 8x squared plus 11x, you're just going to distribute your negative sign. So you're going to go negative x cubed minus 8x cubed squared, and then minus 11. So then when you have two negatives, it becomes a positive, and then you can just add this to your original term. So basically when you have when you're subtracting a polynomial, you can easily turn it into an addition problem and then just do it the way we learned originally. So then we can group these together. So we have 1x to the fourth. So we'll have 2x to the fourth. And we have 2x cubed. So when we add those together, we get plus 4x cubed. We have 1x there. Oh, and we don't have an x there. But we have an x cubed in this statement. We have an x cubed. X cubed in this statement. So we get plus 8x squared. And then we'll take our x from the original statement, minus 3x. And then we have the minus 11. So we basically just added them together. Let's see, is that an answer up here?
It was A.
It was my A.
It went up to the top.
Uh-oh. I added wrong. Let's try a different problem. Okay, so basically we're going to do the same thing for this problem. So, what's my second term going to become if I distribute the negative? Can anybody tell me?
Negative 4AB.
Okay, and then can someone add them together? Nobody knows?
B.
You think it's B? Sounds good. Yep.
Yay.
Okay, can anybody figure out what the coefficient of the second term is? So what's the number in front of the second term when you subtract these two polynomials? Does someone want to come up and subtract it? Or do you need to visually see it? Like, do you need to do it? Or can you do it in your head?
Oh, that's the way
30?
Wait, yeah.
Oh,
Negative 28.
You think it's 30?
No.
Negative 30. You're close though. Okay, and then step by step, can we figure out is this problem solved correctly or incorrectly? So our first step would be to what? Distribute our negative sign. So when we distribute it, is it distributed correctly? Negative 2x squared should be plus a negative 5, right? Yeah. So this is math and kind of things. So quick overview, we learned polynomials, we learned how to successfully group stuff, and how to add and subtract polynomials. And now we can all go on to constructing roller coasters. And then my little trick was, we didn't